All right, for this problem, what we have are two functions. One of them is f, which is this second degree polynomial. It's a second degree polynomial because the highest exponent is a 2. The other function we have is g. It is also a second degree polynomial because the biggest exponent is a 2. What we're being asked to do is to multiply the two functions. We haven't talked a lot about what a function is. So we're gonna set that aside to mostly focus on the mechanical procedural aspects. So the other function is this second degree polynomial. And inside this parentheses, we put an x just because that's the variable. It's the only variable you see. And that is the variable, okay? So when you multiply the two functions, you're multiplying the two polynomials. And they're really trinomials, meaning there's 3 terms and both of them are trinomials. And what we're going to do is distributive property. There's going to be quite a bit to do, but you'll see that as long as we do things in order, we'll be able to keep track of what we're supposed to do. So you always take the first term and you're going to multiply it by each of the 3 terms in the second trinomial. So I'm going to start over here because we're going to need quite a bit of space. X squared times 3x squared is going to be 3. And it's 3 because what you have to imagine is that there's a 1 there. Okay. But it's 3. And then whenever you have x squared times x squared, the rule is to add the exponents. So that might be the most challenging part, is knowing which rule to apply and why. Then we have 1x squared times negative 10x, so that's negative 10. And then x to the second power times x to the first, you add the 2 and the 1, so that's a 3. And then 1x squared times minus 5 is minus 5x squared. So we're done with the first term here. And so just so that things don't get too messy, I'm gonna delete those helpful arrows. And we've got to have some new ones that are gonna help us keep track of what we're supposed to do with a second term, which is multiply it by every term in the second trinomial. Trinomial, yeah. So negative x, remembering there's a 1 here. Negative x to the 1 times 3x squared, that's minus 3x to the third power. You're adding the 1 and the 2. Negative x times negative 10x is positive 10x squared. Then minus x times minus 5 is a plus 5x. Let's get rid of those arrows. And let's now work with the last term in this trinomial that also has to be multiplied across. So it's 3 times 3 is 9x squared. 3 times negative 10x is negative 30x. 3 times negative 5 is 15. So there we go. We've done all the multiplying. The next step is to find like terms. There is only one 3x to the fourth power. By like terms, that means the variable part needs to be the same. So this is going to stay as 3x to the fourth. Then I've got, let's circle them in orange. This term and this term are like each other. So that's going to leave us with negative 10x cubed. Let's take the x squared terms and just circle them in green just to help us keep track of those. And there's one over here. So that's going to be negative 5 plus 10 is 5 plus 9 is 14. And make sure you keep the same variable part. And let's take the linear terms, which is the ones with the x to the 1 power, and combine those. So that's negative 25x. And the last term we're left with is that plus 15. So we're left with what ends up being a fourth degree polynomial. So when you multiply a second degree polynomial with a second degree polynomial, you're going to get a fourth degree polynomial, which means that that's the biggest exponent. There's also relationships between the degree and the kind of picture you get. If it's a second degree polynomial, like the original ones, that's a parabola. Fourth degree polynomials make a specific kind of graph, which we won't get into here because we're just looking for that final answer, which is this here. Now, there's a second part to this, which is has the question here. Basically, it's telling you to plug in a 0 for x. So in a few seconds here, we should be able to complete that piece. What I'm going to do is take our new product of functions and plug in a 0. And that 0 is going to be everywhere you see an x. Since everything zeroes out, we're left with 15. And so the final answer for the second part is 15.